Hi class, this is Eldon, and I have a new micro lecture for you for exercise 11, how to test sentential logic sentences for validity. So here are the instructions. Test the following arguments for validity. For those that are invalid, specify the rows that demonstrate, or row that demonstrates the invalidity. Okay, so I'm going to look at a simple question and then a more complex question because the quiz has some simple and complex ones. So for the simpler question, we have this following argument in sentential logic: not P, therefore not P or Q. So how do you test for validity in sentential logic? So begin by reviewing the truth tables for negation and disjunction. Since negation just changes the truth value, this one is easy to remember. The table for disjunction is on page 129 of the textbook. Next, begin constructing the truth table for the argument. This will include columns for both P and Q, which are the variables in the argument, to the far left. So these are your base columns. The number of rows is determined by the operation to n rows, where n equals the number of variables in the argument. In this case, we have two, P and Q. So columns run up and down, and rows run left to right. Okay, so the operation is 2 to the second power equals 4 rows. Okay, so that's how you know how many rows you need. Truth distribution for the last column is always alternates true, false, and then from there you just alternate by 2. Okay, for 2 terms. So this is true, false. All right. So then place the premises and conclusion in the right-hand columns. In this case, one column for the premise, not P, and one column for the conclusion, not P or Q. Okay. Next, plug in the truth values for negation and disjunction based on their truth tables and the truth values of the terms in each row. Okay. So here what you're looking for is the value of not P, which is here. And then you're looking for the value of Q, which is here. And so then when you look at the truth table for disjunction, you want to look for the value it gives when it has a distribution of false, true, false, false, true, true, and then true, false. And that's how you know what to plug in here. Okay? So to test validity, look to see if there are any rows where the premises or the premise or premises are true and the conclusion false. Okay? So what you do is you look at here to see where there's true, premises, true, and then to see if there's any row where the conclusion is false, but there are none in this case. So the argument is valid. If there are, then the argument is invalid. Okay? So let's look at the complex question now. Here's a complex one. Not P or R. If not Q, then not R. Therefore, P if and only if R. So to prepare, review the tables for, again, negation, disjunction, conditional, and biconditional. The negation one is easy though, so you really want to look for disjunction, conditional, and biconditional, and those are on page 129, 130, and 132 in the textbook. So next, begin constructing the truth table, beginning with the terms P, Q, and R in the left-hand base columns. So notice the truth distribution in the table is going to differ because there are 3 terms, P, Q, and R, instead of 2. So in this case, the operation to determine the number of rows is 2 times 2 to the third power, where n is 3, since there are 3 terms. So we need 8 rows. Since the last column always alternates true, false, etc., we turn to the next column, which is alternates by 2. 2 true, 2 false, 2 true, 2 false. The next alternation will require an alternation by 4. Okay? If there was a 4th term, it would be by 8. What you're doing is you're just trying to get all of the possible sequences of truth with the terms. So this table covers all the possible combinations of truth value for all the different terms. Okay, and if you use these methods, the operations, you'll always have it right. So next, place the premises and conclusion of the argument in right-hand columns. Here we are. Then plug in the truth values for the logical connectives, disjunction, conditional, biconditional, and the terms using the truth tables for the connectives, and the truth values for each term as designated by the rows. Okay, and so here, because we know what the truth of the rows are, we can make the additions to the truth values in the premises, and so list the truth values for the connectives, disjunction, and then conditional. So what you're looking for is a row where the premises, then disjunction and conditional are true, and where the conclusion, biconditional, is false. If there is one, then the argument is invalid, and in this case there is one. Here's a row where both premises are true, yet the conclusion false, so the argument is invalid. Well, that's how you test for validity in SL for simple and complex arguments and sentences. If you have any questions, please feel free to reach out through email or by stopping by virtual office hours.